Alright, welcome back. This is going to be the second part about stoichiometry. In the previous part we learned how to read the mole ratios, and in this portion we're going to change it up, and we're going to go from mass to mass instead of moles to moles. So here is a graphic that will help you see you can go from mass to moles and moles back down to another substance. So right now it doesn't probably make much sense, but maybe at the end of the presentation it will. Alright, so if we're looking at this equation, we have CO2 plus 2 LiOH makes Li2CO3 and H2O. And it's balanced because I see a coefficient in there. And I'm given this problem: how many grams of lithium hydroxide are required to react with 20 grams of CO2? Okay, and in the mole ratio section, we learned that if we can get from moles of CO2, we can go to moles of the lithium hydroxide. So if we remember, we can go from grams to moles of any substance using the mole ratio. So what we're going to do is we are going to convert the grams of CO2 into moles of CO2. And once we've done that, then we can do the mole ratio and change it into moles of lithium hydroxide. And from moles of lithium hydroxide, we can go into the grams that they request. So what we're going to do is converting grams of CO2 to moles of CO2, then moles of CO2 to moles of LiOH, and then converting again moles of LiOH into grams of LiOH. This will be a three-step problem. You'll have a fraction for each one of these segments, and when you're done, you'll have an answer. So let's set up the problem. We're going to start with the 20 grams of CO2, and we need to transfer from grams of CO2 into moles of CO2. So grams would go on the bottom of this fraction, and moles would go on the top. Now, I know that because it's the same substance, I can look on the periodic table and figure out the molar mass of CO2. So I can add up the carbon, the two oxygens, their atomic masses, and I will know how many grams 1 mole of CO2 equals, and it's 44 grams of CO2. Now, I have moles of CO2 here on the top of this fraction, so in order to cancel, it will go on the bottom of the next fraction. I am now at the point where I can go from moles of one substance into moles of the other substance in the problem. So I'm going to relate my moles of CO2 to my moles of lithium hydroxide, and I'm going to use the mole ratio. And remember, mole ratios are the coefficients in the balanced equation. So I have 1 mole of CO2 and I have 2 moles of lithium hydroxide. So I will plug in my equation here, and this is called the mole ratio. Remember from the first part, the mole ratio. So I got my 1 mole of CO2, that 1 came from here, and the 2 moles of LiOH, and that came from here. So in converting and doing dimensional analysis, we know that the units that are here must now go on the bottom of the next fraction. So I'm going to put moles of LiOH on the bottom, and I can relate moles of LiOH into grams of LiOH, because it's the same substance using the molar mass. So I will look up on the periodic table the mass of the Li, the O, and the H, and I'll add them together, and I get 24 grams of LiOH. Now the problem asks me to find the number of grams of lithium hydroxide, and if you look at the units and cancel them out, I am left with grams of LiOH, so my problem is finished. And I have an answer of 22 grams of LiOH. So what this problem is telling me is this: if I have 20 grams of CO2 and I want to use it all completely, I would need to react 22 grams of LiOH in the reaction to completely use up all the substance that I started with. Here's another problem. And a different equation. I have, what is the mass in grams of water produced when 3 grams of oxygen react? Okay, so we're going grams to grams. We have 3 grams of oxygen, we have a balanced equation, and we're being asked to find the grams of water. So we're going to start with our 3 grams of oxygen, and we're going to convert the grams of oxygen into moles. So grams of O2 go on the bottom of this fraction, and we'll put mole on top. And we know that there are 32 grams of oxygen in every 1 mole of oxygen. Okay, we now have moles of O2. We can use our mole ratio to change it from moles of O2 into moles of H2O. And looking at the balanced equation on the top of the screen here, we can see that there is 5 moles of O2 and 6 moles of H2O. So I have to line it up in my fraction form in order to cancel my moles of O2. So it looks like this. Okay, now we have moles of H2O. So in our last fraction, we can go from moles of H2O into grams of H2O. Moles of H2O will need to be on the bottom, and we can add up the H's and the O, and we will get 18 grams of H2O. So we cancel our units, and we can see that we are finished. We have the unit we're looking for. So now we just have to do the math. We take the 3 grams divided by 32 times 6 divided by 5 times 18, and you will get an answer of 2.03 grams of H2O. What this is telling me is this: when I use 3 grams of O2 and I react it completely, I will produce 2.03 grams of H2O. So I now know how to go from moles to moles, and you can see that if you start here with the moles of a substance, I can use my mole ratio and get moles of another substance. And then we just learned today, right now, if I start with the mass of one substance, I can convert it to moles and then change it to moles of a different substance and convert it back out to grams of that second substance using this full path. So as I said in the beginning, this picture might not make sense initially, but now maybe it does.